Hello everyone, welcome to another video. This video is about RL or reinforcement learning. It is a kind of machine learning models and today I will explain about this model and all mathematics behind this. First of all, what is the definition and application? RL is an optimal decision-making problem and usually is a way to solve reward-based problems. And this kind of machine learning model tries to mimic humans' behavior or understanding from the environment, but not from a teacher or a supervisor, but from the interaction with the environment. And the machine tries to maximize rewards by choosing correct action in each situation. And unlike a supervised machine learning model, we cannot have a supervisor here. For example, in machines, when it should be driven without any human action, the machine will face different situation or pictures, and we cannot provide a label for each input, and so it is impossible to have a supervisor in this kind of machine. And in this machine, it tries to maximize reward and minimize punishment. Okay, what is application? For example, this kind of machine have different applications, but for example, an application is in a financial world and in stock market, a machine can decide to hold, sell, or buy a stock, and it is based on the gain from each decision, and the machine should have enough information about financial situation in past, present, and future, and so it is not easy to decide correctly. Okay, now we will go through all mathematics behind RL, and we need here three important definition. The first one is what is a Markov sequence? A sequence of states or Markov if and only if the probability in next step is depends only on our current step. It means that probability in state t plus 1 conditioned by step t is equal to probability in step t plus 1 conditioned by state t s1 to st. Actually, s1 to st minus 1 has or have no influence on our probability. So our next step only depends our current steps. And a time a homogeneous Markov chain is if it is not dependent to uh, time or t, and it means that the probability in step t plus 1 equal to s prime condition when st equal to s is equal to probability in step t condition by step t plus 1. The value is also unchanged. So homogeneous is if our the value of our next step and current step does not depend on t. Now the next definition, it is Markov process. A Markov process or a Markov chain is a tuple of S and T. What is S and what is T? T is a finite set of states, and P is a state transition probability. It means with this probability we will go from, for example, step 0 to step 1, step 1 to step 2, and so on and so forth. Now we will have another definition, and it is a main definition in RL, Markov decision process. A Markov decision process is a tuple from S, A, P, gamma, and R. S is like the last definition, a finite set of states, and A is a finite set of actions. and P is a state transition probability. And gamma is here discount rate or discount factor, and R is our reward. Action means that in order to go to next state, we will have an action or machine have to make a decision, and it is actually this action. And P is like last definition state transition probability, and gamma is here discount factor. I will explain about that now. And R is reward, and it is like that from our current step we will have an action and go to next step, and so it will lead to a reward. The main goal of RL model is to maximize reward, cumulative reward, and it means that we will maximize all reward that we can gain in the time, all time, and also future. But we do not have enough information about future, and so our current reward is better than future reward, and so we should consider future reward uh, with a discount factor. So we have here a discount factor for our future rewards, and we have this sigma, which will consider our current reward and future reward, and our goal is maximizing this value. Um, it means that we will have we want to have a action or a path for actions which will lead to a maximize amount of reward. Again, about discount factor, why we have this factor? Discount factor will help us to avoid infinite returns in Markov process. And also we have uncertainty about future reward. And in finance, immediate reward is better than future reward. And the last reason is animal and human behavior will lead to an immediate reward. And so we will have a discount factor for our future reward. Now we will have another important definition, and it is policy. But what is exactly policy? Policy is a strategy that will tell us or dictates machine um, how um, take action from a state in order to maximize our reward. So we have to choose or determine our optimal policy in order to maximize rewards. To do that, we need another two elements, which are state value function and action value function. This function is a state value function, and it is expectation of a reward from state t with value s. And this is action value function. It is expectation of this reward from state t with action at equal to a. And it is all by consideration this policy p. So action value function and state value function are expectation of our reward from a state while considering a specific policy. So now how we need to calculate our optimal policy. First, I should mention this Bellman equation because we need that to be able to obtain optimal policy. For simplicity, we name this expectation of reward in step t plus 1 by consideration step t with this action in step t. We name this as RSA, and we will rewrite this equation for state value function and action value function like this, and we these two equations are called Bellman equation for state value function and action value function. Now we need to have a definition for optimal state and action value function. It means that optimal value for state value function is maximum value for all state value function under consideration all policy, and the same optimal value for action value function is maximum value action value function for all policy. And we have also here this relationship. It means um, the policy P is larger or equal to policy P prime if the value of state value function for each state um, for action P for policy P is larger or equal to the value of state value function for policy P prime and all state. And by this definition, we will have next theorem, and this theorem will guarantee that we will have a optimal policy. Um, there exists an optimal policy, and it is P star that is better than all other policies. It means that it is larger equal to all other policies, and all optimal policy achieve to optimal value for state value function, and also we will have for optimal policy optimal value for action value function. So we can find um, optimal value for a policy by finding optimal value for a value function. And also we can have this one that we can have this optimal policy by maximizing action value function. It means that we if we can determine the best action with that we have maximal value of action value function, we will have also the definition of our policy. Now I want to explain two algorithms, and by them we can obtain optimal policy. The first one is policy iteration. In this algorithm, we should start from a random value of policy, and it means we can start from a random action for every state. And in step two, we should evaluate our policy or action, and we can do that by Bellman equation, this equation. And in the last step, we should improve our policy, and it means that we can obtain the best action for each state from value function, and we will do that by this equation and maximizing this value. Another algorithm is the value iteration, and in this equation, in this algorithm, we should start from an initial value for state value function, and it is 0. And in the next step, we should start a for loop or a while loop and improve in each step out the value of state value function and update its value. And we will do that by maximizing this value. In each iteration, we should maximize this value, replace the value function, and go to have best value of our state function, which is equal to have optimal policy. So that was short definition and explanation about RL, what is RL and what is the mathematics behind RL. If you have any question, please ask me in comments, and if you find this video useful, please subscribe to my channel. I will upload more videos about machine learning and mathematics and subjects like that. Okay, thank you. Bye.